Hello everybody, welcome into another lesson. So today we are going to talk about using inverse matrices to solve a 3x3 system of equations. So here again you have your three variable system of equations with various coefficients on the x, y, and z variables. And then to the right you have what those equations are equal to the right side the equal sign. Much like in a 2x2 system, for matrix A, you could separate all this into matrices A, X, and B. Matrix A is going to be a 3x3 matrix just representing the coefficients of your X, Y, and Z variables. This time matrix X will be a 3x1 matrix which would just have variables X, Y, and Z. And then matrix B is going to have a 3x1 matrix with everything to the right of the equal sign. Well, it's the same idea as a 2x2 matrix. You take your AX, which would equal B. In order to solve for X, you take A inverse times B. Well, as we know, the inverse of a 3x3 matrix is not nearly as pretty as a 2x2 matrix, as evidenced by yesterday's lesson. So we're going to do 3 examples and show you how that works. There will probably be frequent erasing of the board just so we don't run out of room. So let's go ahead and get started. So in this case we have the system x minus 4y plus 5z is equal to negative 4. We have 2x plus y minus 7z is equal to negative 23. And then we have negative 4x plus 5y plus 2z is equal to 38. Yeah, not pretty at all. But let's go ahead and set up our 3 separate matrices here. So matrix A is simply going to be a 3x3 matrix with your coefficients of x, y, and z. So your first row, you'll have 1, negative 4, and 5. Second row, you'll have 2, 1, and negative 7. Third row, you'll have negative 4, 5, and 2. So there's your matrix A. Matrix X is simply just going to be a 3x1 with variables x, y, and z. Then matrix B will just be a 3x1 matrix with everything to the right of the equal sign, the negative 4, negative 23, and 38. All right. So in this case now we've separated our matrices here. We have matrices A, X, and B. Well, we want to find the inverse of matrix A. So take this matrix A, set it into a double augmented matrix. So you'll have the 1, the negative 4, and the 5. And then to the right of the augmented line you'll have the identity matrix, 1, 0, 0. Then let's see, you'll have second row 2, 1, negative 7, 0, 1, 0. Third row you'll have negative 4, 5, and 2. And then to the right you'll have 0, 0, 1. Now we're just going to perform some elementary row operations. The idea is let's make the first digit in the second and third row become 0 to start with. So if I take negative 2 times row 1 and add that to row 2, I can make it happen there. And if I take 4 times row 1 and add that to row 3, I can make it happen in that row. So let's go ahead and set this up here. Row 1 stays the same for the time being. Yes, this is quite horrible. Alright, so negative 2 times 1 is negative 2 plus 2 is 0. All right, negative 2 times negative 4 is 8, plus 1 is 9. Negative 2 times 5 is negative 10, plus negative 7, that'd be negative 17. So negative 2 times 1 is negative 2 plus 0, that'd be negative 2. Negative 2 times 0 is 0, plus 1 is 1. Then negative 2 times 0 is 0, plus 0 is still 0. And then let's deal with row 3. So 4 times 1 is 4, minus 4 is 0. 4 times negative 4 is negative 16, plus 5 is going to be negative 11. 4 times 5 is 20, plus 2 is 22. 4 times 1 is 4, plus 0 is 4. Man, then let's see, 4 times 0 is 0, plus 0 is still 0. 4 times 0 is 0, plus 1 is 1. So there's our new row 2 and 3. Next thing I can honestly suggest is we should make the second digit in row 3 also a 0. Well, if I take 11 times row 2 plus 9 times row 3, I can make that happen. So 11 times row 2 plus 9 times row 3 will get me that second digit in row 3 becoming a 0. So row 1 stays left alone for now. Row 2 will even leave alone for the time being. Alright, so 11 times 0 is 0, plus 9 times 0 is still 0. 11 times 9 is 99, plus 9 times negative 11, that's negative 99. That'll give you 0 there. Good grief. Let's find 11 times negative 17. That'd be negative 187, and then 22 times 9 is 198. So negative 187 plus 198 is positive 11. And then, let's see here. 11 times negative 2 is negative 22. Plus 9 times 4 is 36, so 36 minus 22 is going to be 14. Alright, 11 times 1 is 11, plus 9 times 0 is 0, so you end up having 11. 11 times 0 is 0, plus 9 times 1, that's 9. Alright, well, the only thing left to do at this point is to make the leading digit in row 3 a 1. So we're going to have to take 1/11th of row 3. That's the only thing we have left to do at this point before we can go any further. So rows 1 and 2 will be left alone. Alright, so 1/11th of 0 for both of them is 0. 1/11th of 11 is 1. 1/11th of 14, that's simply going to be 14/11ths. 1/11th of 11 is 1. 1/11th of 9 is 9/11ths. Alright, so we have the reduced row 3. Now, the next goal is to get the third entries of rows 2 and 1 to become 0. We'll do that. So what we need to do to convert row 1, we take negative 5 times row 3, add that to row 1, and then we'll take 17 times row 3, add that to row 2, we should be able to make that happen in both rows. So row 1 is still left, well, no, row 1 is not left alone. So between rows 3 and 1, so all right, negative 5 times 0 is 0, plus 1 is still 1. And then negative 5 times 0 is 0, plus negative 4 is still negative 4. Now, negative 5 plus 5 is 0. All right, and then we have negative 5 times 14 elevenths is negative 70 elevenths, plus 1. So negative 70 plus 11 is negative 59 elevenths. And then negative 5 times 1 is negative 5, plus 0 is negative 5. And then negative 5 times 9 elevenths is negative 45 elevenths, plus 0. That's what you'll get, negative 45 elevenths. Now, between rows 3 and 2, 17 times 0 is 0, plus 0 is still 0. 17 times 0 is 0, plus 9 is still 9. And then we have, let's see, 17 times 1 is 17, minus 17 is 0. All right, 17 times 14 elevenths, holy cow. Take 17 times 14 is 238, plus that 2, which would be 22. That would give you 260 elevenths. So you'll end up having 260 elevenths here. And then 17 times 1 is 17, plus 1 is 18. And then 17 times 9 elevenths plus 0. Well, the plus 0 part's easy. We just got to take 17 times 9. That would give you 153 elevenths. And then you still have your row 3, which is entirely left intact. What a mess, huh? Okay. Next thing we probably want to do is take 1/9 of row 2 to make the leading digit a 1. So let's take 1/9 of row 2. So row 1 still gets left alone for now. Alright, 1/9 of 0 is still 0. 1/9 of 9 is 1. 1/9 of 0 is 0. Now, 1/9 of 260 times 11, that would be 260 99ths. Whoops, I forgot to write all these other entries in the first row. Let me write those real quick. So that'd be 260 99ths. Let's see, 1/9 of 18 is just simply 2. And then you would have 153 99ths here. Then you have your final row, which is 0, 0, and 1, which would give you 14 elevenths, 1, and 9 elevenths. That just looks horrible, doesn't it? Does 153 reduce at all? I'm just curious. Yeah, 153 reduces actually, so that would reduce to 51 33rds. Actually, it's 153 divisible by 9. That'd be 17 elevenths. So the last entry here in the second row would actually end up being 17 elevenths. It reduces down to 17 elevenths, so that makes life a little bit better. I don't think 260 reduces any further. Nope, it doesn't. We're just stuck with 260 99ths. Okay. Last thing we want to do now is get that second digit in row 1 to become a 0. So we have to take 4 times row 2 and add that to row 1 to make that happen. So why don't I erase some of this here? If you need help with this, you can always rewind the video. It's just I'm running out of room. I'm definitely running out of room here. So let's go ahead and erase everything except for this last one that we just did. Alright, so we're going to take 4 times row 2 and add it to row 1. Well, 4 times 0 is 0, plus 1 is still 1. 4 times 1 is 4, minus 4 is 0. 4 times 0 is 0, plus 0 is still 0. Good Lord. 260 99ths times 4. Let me do this on the side. That would end up giving me 260, so that'd be 520, 1040, I believe. Yep, 1040 99ths. Minus, now we want them to have the same denominator, so if we're just adding it to negative 59 elevenths, we need to multiply negative 59 by 9. That'd be minus 531 99ths. Which is going to end up giving you 509 99ths. Our only saving grace may be if we have any way to reduce this. I don't think we do, but let's see. Nope. So that means the first entry here to the right of the augmented sign would be 509 99ths. Alright, so then you see 2 times 4 is 8, minus 5 is 3. That's a nice simple one. And then 4 times 17 elevenths, that's going to be 68 elevenths, minus 45 elevenths. That would just be 23 elevenths, so that's not as bad. Alright, and then row 2 and 3 we can just leave alone. We already got it now. We already got those reduced. So you have 260 99ths to 17 elevenths. Row 3 stays left alone since it's already reduced. So we have 14 elevenths, 1 9 elevenths. Well, we have the identity matrix on the left now. This gives us whatever's to the right of the augmented matrix to be our identity matrix. So this means your A inverse is going to be everything to the right of this augmented line. So you'll have the 509 99ths, the 3, the 23 11ths, the 260 99ths, the 2, the 17 11ths, the 14 11ths, the 1, and then the 9 11ths. So here is your inverse of A matrix. And you can see why I say this is not a preferred method. We definitely don't prefer to do it this way, because for it wasn't so bad for a 2 by 2, but for a 3 by 3, my gosh. But it's still true that X equals A inverse times B. That hasn't changed. So we'll take our A inverse matrix of 509 99ths, 3, 23 11ths, 260 99ths, 2, 17 11ths, 14 11ths, 1, 9 11ths. We're going to multiply all that times the B matrix here, which was -4, -23, and then 38. You have a 3 by 3 times a 3 by 1, you should just get a 3 by 1, get your direct values of X, Y, and Z. So we know A inverse now. Let me erase this for room's sake. So let's see. You'll end up getting 509 99ths times -4 plus your 3 times your -23 plus your 23 11ths times your 38. That's all your first row. Your second row, you'll get 260 99ths times -4 plus 2 times -23 plus 17 11ths times 38. Now you'll take 14 11ths times your -4 plus 1 times -23 plus the 9 11ths times your 38. So all this awful thing. Alright, so this is going to simplify into 509 times -4. Let's figure out what the heck that is. -2036 99ths. We want everything to have the same denominator. So 3 times -23 is -69. So -69 times 99 would give you -6,831 99ths. Alright, then let's see. Let's take 23 times 8. Sorry, 23 times 38. 874, but we have to multiply that by another 9 to make our denominators the same. That'd be plus 7,866 99ths. That's all row 1. Row 2, 260 times -4 negative 1040 99ths. And then, alright, so 2 times negative 23 is negative 46, but we got to multiply that by 99 to get the same denominator. So negative 46 times 99, negative 4,554 99ths. So minus 4,554 99ths. Then you're going to take the 17 times 38. Let's figure out what the heck that is. That'd be 646, but then you got to take that 646, multiply that by 9 to have the same denominator. That'd be 5,814 99ths. Then we got a row 3. So 14 elevenths times negative 4. The good news is we only have to do a denominator of 11 in row 4. That's just going to give you negative 56 elevenths. Alright, plus 1 times negative 23. That's going to be negative 23. But we need to take that negative 23 and multiply it by 11 to have the same denominator. That'd be minus 253 elevenths. And then 9 times 38, let's figure out what that is. That'd be 342 elevenths. Alright, here's the moment of truth. So, let's do all the math now. Negative 2036 minus 6831 plus 7866 gives you negative 1001 over 99. Which would end up giving you negative 91 over 9. You'd end up getting negative 91 over 9. And then let's do the second row. So let's see, negative 1040 minus 4554 plus 5814 would give you 220 over 99. So that would end up being 20 over 9. That would just be 20 over 9 when you reduce it. Then we have the final row. Negative 56 minus 253, negative 309 plus 342 gives you 33 over 11, which is just 3. So there's our X matrix now, which is negative 91 ninths, 20 ninths, and 3. So the ordered triple that's going to be our solution is negative 91 ninths, 20 ninths, and then 3. That would be the ordered triple that represents the solution. So you see why I'm saying this is the least preferred method to figure out the system, to figure out what the ordered triple is. It seems to be a lot more work than you need to do, and really it is. But I still gotta teach it. Because you may be asked to solve a system using inverse matrices only. This is way worse than using Cramer's rule to solve it. Next system, we have 3x minus y plus 4z is going to equal 16. We have 2x plus 4y minus z is going to be equal to 10, then we have x minus y plus 3z is equal to 31. So there's the system. So here's this system. Let's set up our three separate matrices. So A, of course, is just the coefficients of your variables. So that'll be 3, -1, 4, 2, 4, -1, 1, -1, and 3. There's your A matrix. Let's figure out your X matrix. That's just the variables X, Y, and Z. That would just be a 3 by 1 with X, Y, and Z as your entries. Then your B matrix is going to be everything to the right of the equal signs, the 16, the 10, and the 31. That is your B matrix. All right. Well, we definitely want to find the inverse of A. So let's go ahead and set up an augmented matrix here, a double augmented matrix. The 3, the -1, the 4. Then to the right, you'll just do the identity matrix. So then you'll have 2, 4, -1, 0, 1, 0, 1, -1, 3, 0, 0, 1. First thing I'm going to even suggest is that we go ahead and swap rows 1 and 3 because you want the leading digit in row 1 to be a 1 for your X coefficient. So we're just going to do a simple row swap between rows 1 and 3. Nothing too crazy just yet. So row 3 just became row 1, so you'll have 1, -1, and then 3. And then you'll have 0, 0, 1. Row 2 was left alone for now. The 2, the 4, the -1, 0, 1, 0. And then row 1 became row 3. You'll have 3, -1, 4, 1, 0, 0. All right. So, of course, let's get the first digit in rows 2 and 3 to become 0. So if I take -2 times row 1 and add that to row 2, then if I take -3 times row 1 and add that to row 3, I can make that happen in both rows. So let's proceed to doing that now. Row 1 gets left alone, the 1, -1, and 3. So let's see, 0, 0, 1. All right, now, -2 plus 2 is 0. -2 times -1 is +2, plus 4 is 6. -2 times 3 is -6, minus 1 is -7. -2 times 0 is 0, plus 0 is still 0. -2 times 0 is 0, plus 1 is 1. -2 times 1 is -2 plus 0. That's just going to be -2. All right, now let's deal between rows 1 and 3. So -3 times 1 is -3 plus 3 is 0. -3 times -1 is +3, minus 1 is 2. And then we have, let's see, -3 times 3 is -9, plus 4 is going to be -5. And then we have, let's see, -3 times 0 is 0, plus 1 is still 1. -3 times 0 is 0, plus 0 is 0. -3 times 1 is -3, plus 0 is -3. So we've accomplished one goal. So I'm going to suggest now we make the second digit in row 2, in row 3 a 0. That can be done by, if I take negative 1/3 of row 2 and add that to row 3, I can do it. So let's take negative 1/3 of row 2, add that to row 3, I'll get the reformed third row. So row 1 is not affected just yet. 1, negative 1, 3, 0, 0, 1. Alright, row 2 itself is still not affected just yet. Whoops, that's wrong. Hold on a minute. 0, 1, negative 2. There we go. Alright. Let's see, so negative 1/3 of 0 is 0, plus 0 is still 0. Negative 1/3 of 6 is negative 2, plus 2 is 0. Negative 1/3 of negative 7 is actually going to end up being, well, yeah, what is negative 1/3 of negative 7? That's positive 7/3 minus 5. So that'd be 15/3. So 7/3 minus 15/3, that's negative 8/3. Alright, now, negative 1/3 of 0 is 0, plus 1 is still 1. Negative 1/3 of 1 is negative 1/3 plus 0. That'd be negative 1/3. Now, negative 1/3 of negative 2 is positive 2/3 minus 3. So 2/3 minus 9/3 would be negative 7/3. So at least you have 2 zeros now in row 3, but let's start out by making that leading digit a positive 1. The leading digit right now is negative 8/3. That means we need to take the row 3 and multiply by negative 3/8. So let's take negative 3/8, multiply that by row 3, and we should balance it out to make the leading digit a 1. So rows 1 and 2 are not just yet affected. They will be eventually, but not right now. Row 2 we are leaving alone for just a minute. Alright, so negative 3/8 times both zeros is 0. Negative 3/8 times negative 8/3 is 1. Negative 3/8 times 1 is, well, negative 3/8. Negative 3/8 times negative 1/3 is going to end up being positive 1/8. Negative 3/8 times negative 7/3 would end up being positive 7/8. So great, we've just reduced row 3 how we need to. Row 3 is fully reduced. We need to do nothing else with it. Now, what I'm going to suggest here is we go after the third digit in rows 2 and 1. To get rid of those third digits, make those all 0, okay? So let's deal between that and row 1. If I take negative 3 times row 3 and add that to row 1, I can make the third digit in row 1 become 0. And then if I take 7 times row 3 and add that to row 2, I can make it happen in row 2. And it's nice you can do more than one row at a time. It saves you some time. So let's see, negative 3 times 0 is 0, plus 1 is still 1. That hasn't changed. Negative 3 times 0 is 0, minus 1, still minus 1. Alright, negative 3 times 1 is negative 3, plus 3 is 0. That's the first change we've made to row 1. Alright, now, negative 3 times negative 3/8, that's positive 9/8 plus 0. You'll get 9/8. And then negative 3 times 1/8, well, that's negative 3/8 plus 0. That's negative 3/8. And then you have negative 3 times 7/8, that's negative 21/8 plus 3/3, that would be negative 18/8. Negative 18/8 here. I'm just going to leave all these as the same denominator for a minute. I know it's not reduced yet, but there's a reason I'm doing that. Alright, now between rows 3 and 2. 7 times 0 is 0, plus 0 is still going to be 0. 7 times 0 is 0, plus 6 is still 6. 7 times 1 is 7, minus 7 is 0. Alright, 7 times, let's see, yeah. 7 times negative 3/8 is negative 21/8 plus 0. Well, there's just your negative 21/8. And then you're going to end up having 7 times 1/8 is, well, that's going to be 7/8 plus 1, which is 8/8. That would give you 15/8. And then you'll have 7 times 7/8, that's 49/8, minus 16/8, that would end up being 33/8. Then you still have your row 3, which we don't really need to touch because it's already reduced as far as it can go. Alright. Before we can do anything else, we need to make the leading digit in row 2 a 1, which means we need to take 1/6 of row 2. So let's go ahead and do that here. 1/6 of row 2, which means it's time to erase. Unfortunately, I need to erase some stuff in order to make space. But feel free to rewind the video as much as you need, so you can see how I got from where to where. I know, these are some loaded problems. Okay, so let's start over here then. Row 1 at the moment is unaffected. 9/8, negative 3/8, negative 18/8, and then, alright, right to row 2. So 1/6 of 0 is 0, 1/6 of 6 is 1, 1/6 of 0 is still 0, 1/6 of negative 21/8. Let's make that, for the time being, let's make that negative 21/48. Negative 21/48, if you divide each by 3, you'll end up getting negative 7/16. So you end up getting negative 7/16. And then, alright, 1/6 of 15/8 is going to end up being 15/48. Divide each by 3, you'll get 5/16. So this entry here is 5/16. Then take 1/6 of 33/8. That's going to end up being 33/48. Which, divide each by 3, you'll end up getting 11/16. So there's 11/16 for your entry. And then, let's see here. Row 3 we can leave alone. You have 0, 0, 1, negative 3/8, 1/8, 7/8. The only thing left to do now is make that second digit in row 1 a 0. We can accomplish that by simply adding row 2 to row 1. It'll be real easy then. If I add row 2 to row 1, I'll make that happen. So let's see here. You'll have 0 plus 1 is still 1. 1 minus 1 is 0. 0 plus 0 is 0. Negative 7/16 plus 9/8. Let me just do that work down here on the side. Plus 9/8. Well, that's going to equal negative 7/16 plus 18/16. Well, that's going to give me 11/16. So I'll end up getting 11/16 for my first entry in row 1. And then let's see, we have 5/16 minus 3/8, which equals 5/16 minus 6/16, which would equal negative 1/16. So you have negative 1/16 here. And then for your final entry, you'll end up having 11/16 minus 18/8, which would be equal to 11/16 minus 36/16, which would give you negative 25/16. So it's probably a good thing I didn't reduce the fraction right there, because I would have just had to remultiply stuff. Doesn't make sense to do the same work twice. So there is row 1 finally in reduced row echelon form. Now let's deal with writing the rest of the rows. So you have 0, 1, 0, negative 7/16, 5/16, 11/16. Then the final row, 0, 0, 1, negative 3/8, 1/8, and then 7/8. Yowzer. So now you have the identity matrix on the left of the augmented line, which means everything to the right is actually your inverse matrix. So congrats, we just found our inverse matrix. But we're still not done yet. We need to use it to solve this system. So A inverse, that matrix is going to end up being 11/16, negative 1/16, negative 25/16, then negative 7/16, 5/16, 11/16. Final row, negative 3/8, 1/8, and then 7/8. So there is your A inverse. Now, it's a true statement that X equals A inverse times B. Let the work begin. So X is going to equal this whole matrix here, 11/16, negative 1/16, negative 25/16, negative 7/16, 5/16, 11/16, negative 3/8, 1/8, 7/8, all that times matrix B, which is a 3 by 1, which would give you 16, 10, and 31. So let's do the multiplication. You should get a 3 by 1 matrix that represents X. So first row, you'll take 11/16 times your 16 minus 10, sorry, minus 1/16 times 10 minus 25/16 times 31. Second row, you'll take negative 7/16 times your 16 plus 5/16 times your 10 plus 11/16 times your 31. And then we still have the third row. You'll take negative 3/8 times 16 plus 1/8 times 10 plus 7/8 times 31. So, yowzer, that's a long one. I'm going to erase this stuff up here. Which means X is going to turn into, so I'm not going to reduce this just yet. Let's just leave our denominators alone for a minute. So let's see, 11 times 16 gives you 176 over 16 minus 10 over 16. Good grief, let's figure out negative 25 times 31. That'd be negative, so minus 775 over 16. Second row. So we'll have, let's see, negative 7 times 16. Negative 112 over 16. Plus 50 over 16. Then we got to figure out 31 times 11. Plus 341 over 16. And then last but not least, we'll have, let's see, only a denominator of 8, so you'll have negative 48 over 8 plus 10 over 8 plus 217 over 8. Let's erase this so I can write the solution here. There's only one more example after this, then we're done. So now let's just do the straight up math in each of the rows. Alright, so 176 minus 10 is 166. Minus 775, that's minus 609. So negative 609 over 16, does that reduce any further? Well, it couldn't because even and odd numbers there, so no, it couldn't. So first entry, which will represent your x value, is negative 609 over 16. What about y? Let's figure this out. So negative 112 plus 50 is negative 62 plus 341 is 279 over 16. Those also won't reduce any further. And then we have the final row. Negative 48 plus 10 is negative 38 plus 217. That's 179 over 8. So now we have our x, y, and z values, giving us the order triple that's the solution for this system of negative 609 sixteenths, 279 sixteenths, and then 179 eighths. That is the ordered triple that represents the solution to this particular system of equations. Hideous. And I got one more, then we're done with this lesson. Actually, after that, we're done with matrices entirely. Probably to many of you guys is relief, because we've spent so much time on matrices, but it is necessary. Last one here. Oh, good one. X plus z equals 9. Negative x minus y plus 2z equals 6. 2x plus 7y minus z equals negative 4. Alright, so there's the last system we're working with. So we have x plus z equals 9, negative x minus y plus 2z equals 6, 2x plus 7z minus y equals negative 4. Well, let's separate our three matrices here. Matrix A is the coefficients of all your variables, so the first row you'll have 1. There is no y entry, so the default entry for that will be 0. And then your z has a 1. And then you have your second row, you'll have negative 1, and 2. And then for your third row, you'll have 2, 7, negative 1. So there's your coefficient matrix of A. X, again, is simply just going to be x, y, and z. And then your B matrix is going to end up being the 9, 6, and negative 4. Alright, so we want to find the inverse of A. To begin with, let's go ahead and set up our double augmented matrix. So 1, 0, 1, to the right the identity matrix, 1, 0, 0, and then you'll have negative 1, 2, to the right 0, 1, 0, and then third row 2, 7, negative 1, and then to the right 0, 0, 1. There you go. One thing that's nice is in row 1 the second digit's already a 0, so we got some of our work cut out for us. Now we want to make the first digit in rows 2 and 3 become 0. So easy enough, if I just add row 1 to row 2, I can make that happen there. If I take negative 2 times row 1 and add it to row 3, I can make it happen there. So let's go ahead and deal with that. So row 1 we're still leaving alone for the time being. Alright, so let's see. 1 minus 1 is 0. 0 minus 1 is still negative 1. 1 plus 2 is 3. Let's see, 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 0 is 0. Alright. Now, negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 0 is 0, plus 7 is still 7. And then negative 2 times 1 is negative 2, minus 1 is negative 3. Alright, then negative 2 times 1 is negative 2 plus 0 is negative 2. Then negative 2 times 0 is 0, plus 0 is still 0. Negative 2 times 0 is 0, plus 1 is 1. Alright, so we have the first digits in rows 2 and 3 as a 0. Next thing I suggest is we make the second digit in row 3 also a 0. That's easy. If I just take 7 times row 2 and add it to row 3, I can certainly do that. So row 1 we'll still leave alone for now. Row 2 we're still not changing just yet. But row 3, so 7 times 0 is 0, plus 0 is still 0. 7 times negative 1 is negative 7 plus 7, turns that into 0. 7 times 3 is 21, minus 3 is 18. And then 7 times 1 is 7, minus 2 is 5. Whoops, I did forget to write everything in row 2. There we go. And then 7 times 1 is 7, plus 0 is 7. And then 7 times 0 plus 1 is 1. Alright. Well, something that's going to temporarily save us fractions, at least, well, not really. Not really, it doesn't. First thing I think we should do is make the leading digit in row 3 a 1. So that means we need to take 1/18 of row 3. This is where it's going to turn a little hideous. Unfortunately, there's just no way around it this time. So row 1 stays the same, for the time being at least. Okay. So row 2 we still haven't affected just yet. That's still staying the same for this part at least. But what about row 3? So 1/18 of both zeros, well, that's still going to give you 0. 1/18 of 18 turns into 1. 1/18 of 5 is 5/18. 1/18 of 7 is 7/18. 1/18 of 1 is, well, 1/18. So now we finally reduced row 3. Next thing I'm going to suggest is that we make the third digit in rows 2 and 1 a 0. Well, if I just take the negative of row 3 and add that to row 1, I can make it happen there. And then if I take negative 3 times row 3 and add it to row 2, I can make it happen there. Alright, so negative 0 plus 1 is still 1. Negative 0 plus 0 is still 0. Negative 1 plus 1 is 0. And then let's see, negative 5/18 plus 1, that would be plus 18/18, so that would give you 13/18. Let's see, negative 7/18 plus 0, well, it's just that, negative 7/18. And then negative 1/18 plus 0, well, just that, negative 1/18. Now let's see, Let's deal with row 2. Negative 3 times 0 is 0, plus 0 is still 0. Negative 3 times 0 is 0, plus negative 1 is still negative 1. Negative 3 times 1 is negative 3, plus 3 is 0. Alright, so negative 3 times 5/18. Good news is, okay, so that's going to end up being negative 15/18, which would actually reduce to negative 5/6. Negative 5/6 plus 6/6 would be 1/6. So we have smaller denominators to work with in row 2. So let's see, negative 7/18 times 3, that would turn into negative 21/18, which would be negative 7/6 plus 6/6. That would give you negative 1/6. And then negative 3/18 is negative 1/6 plus 0. That would also give you negative 1/6. And then we have 0, 0, 1 with all these values. Now, it might almost appear that we're done, except for one thing. The leading digit in row 2 is a negative 1. It needs to be a positive 1. So that's actually a real easy fix. All we have to do is negate row 2, and we'll actually have it then. So leave row 1 alone. That's already reduced enough in the way it should be. Alright, row 2, you just negate that. You'll get 0, 1, 0. Then negative 1/6, positive 1/6, and positive 1/6. Row 3, you just leave that alone. 0, 0, 1. You'll have 5/18, 7/18, and 1/18. I know, it's awful, but we now have the identity matrix on the left, which means everything to the right of the augmented line is your A inverse. So let's go ahead and erase everything before that, and we'll set up our inverse matrix. Alright, so that means your A inverse is going to end up being 13/18, negative 7/18, negative 1/18, and then let's see, negative 1/6, positive 1/6, and another positive 1/6. Then you'll end up having 5/18, 7/18, and then 1/18. So there's your inverse matrix of A. So the idea is, again, X is going to be equal to that A inverse times B. So let's go ahead and set this up real quick. X is going to equal, let's write this whole frickin' thing again, the 13/18, negative 7/18, negative 1/18, negative 1/6, 1/6, 1/6, 5/18, 7/18, 1/18, all that times your matrix B, which is going to end up being 9, 6, and -4. I think now we can erase this part because we know exactly what we're doing here. Alright, so 3 by 3 times a 3 by 1 will give you a 3 by 1 for what x equals. So we will take 13/18 times 9 minus that 7/18 times 6 minus 1/18 times -4. Now let's start in row 2. So you'll take your -1/6 times your 9 plus 1/6 times 6 plus 1/6 times -4. In the final row, you'll take your 5/18 times 9 then you'll take your 7/18 times 6 plus 7/18 times 6, and then you'll take 1/18, so plus 1/18 times -4. So there's your work of that. So let's see here. 13 times 9, so 108 plus 9 is 117/18. I'm going to leave the denominators the same just for a minute. Alright, so that'd be then minus 42/18 plus 4/18. Alright, second row, you'll have minus 9/6 plus 6/6 minus 4/6. Third row, you'll end up having 45/18 plus 42/18 minus 4/18, which now is going to simplify into, let's figure all this out here. 117 minus 42, 75 plus 4, that's 79/18. So first row, you'll get 79/18, and that doesn't reduce any further, unfortunately. So that's your x solution. So let's see, -9 plus 6 is -3, minus 4 is -7/6. As we know, that doesn't reduce any further. So there's your y solution of -7/6, and then let's do for the z solution. So let's see, 45 plus 42 is 87 minus 4, that's 83/18, so that's not going to reduce any further. So now you have your z solution also, which means the ordered triple that is your solution is going to be 79/18, -7/6, and 83/18. That is the ordered triple that ends up being the solution to this system of equations. So there you go. That's how you use inverse matrices to solve a 3 by 3 system. And again, full disclosure, I don't recommend using this method if you are allowed to use other methods such as Cramer's rule or elementary row operations with Gauss-Jordan elimination to either get into row echelon form to use back substitution or into reduced row echelon form to figure out your direct solution that way. This is the least favored method. So we're actually done with matrices altogether now in systems of equations. The very next lesson we will start the unit on quadratic equations, which the very next lesson we'll talk about graphs of quadratic equations and more about them. So I hope everyone has a great day. Take care.